Okay, so this was a great start into the second session. And the next presentation is going to be measuring YouTube quality experienced by end users by Deep Mehdi. I hope I got that right.
Very
Welcome.
good. Okay, so which one is the clicker here? Where is the clicker for that? Is there a clicker for this or, excuse me?
Sorry?
Is there a clicker? Or,
Should be? Yeah.
this one?
The green one should be forwarding your slides, yeah.
Good.
On the red one.
Fantastic. Good afternoon, everybody. It's going to be tough to follow Tim's talk. It was, talking about Disneyland and all this cool stuff. So I'm going to talk about YouTube land for a little bit. And so bear with me. This work is with a couple of people here. Manson Parikshit is my student. Louis was the culprit who actually got me involved into getting this started a couple of years back. And Yang Zhang is a colleague with me at the University of Missouri, Kansas City. So what we actually were trying to do was trying to see is that what can we do about quality of experience with YouTube in terms of being able to measure it. And as you know, YouTube is the most probably watched video service by residential users. So where focus was mostly from the point of view of residential users. And if you look at, there has been some work with YouTube measurement studies over the last several years since it became very popular. And you can actually think about those in two pieces. One is the active approach, the other one is the passive approach. The passive approach is you put a monitor somewhere in the middle of it from where you go to YouTube servers, wherever they're located, get the collection of that information. While this is good, the problem with that is that it doesn't go all the way to the end user. It's only to that particular collection point. But it's easier to collect a lot of data that way. That's one advantage, obviously. So then you can think about what about active approach. If you take the active approach, one possibility is that you can do some kind of a crowdsourcing technique and get some sort of a subjective study. So, and you collect it, see that what the users found it, and it's a valid way to do a lot of studies that way. It's very common to do subjective studies in field like psychology. And the issue we thought was that it is hard to get some of the precise information that we are interested in. For example, you guys all are familiar with that circling thing in YouTube, which is the stalling or the interruption. So if you want to know how long were each of the interruptions precisely in terms of seconds or milliseconds, whatever unit you want, how many times, we will also want to collect it. If you ask a user to collect this, well, maybe it was 3 times I got interrupted, then they forgot. So it builds in inaccuracy into your measurement system if you ask opinion in that sense. So we try to see that is there another way to be able to do that. So then when you look at another approach would be that if you're familiar with Planet Lab, the environment which allows you can run bots from different places to collect the data. That will be almost like an end user doing it. The difficulty, or rather the skewed view of that, is that those are located on university campus networks, which have very good connectivity in terms of internet services. So the amount of stalling or interruption that you will see on a campus network, even from different parts of the world, it's much less than what you would suspect the user. So that's where we wanted to have sort of a ability to do something a little bit differently. So that's basically what led us to think about this thing. And so we basically have 3 goals. We want to be able to, in the context of quality of experience, collect the metrics that is associated with it, being able to measure it, and then being able to measure it precisely. Second thing, we want to be able to see if we can compare residential users in different ISPs, end users, how they are actually seeing by going to a particular video, for example. And third one is at least have some idea about how the YouTube's content CDN, obviously we are not trying to find out the entire CDN architecture of YouTube, but for the ones that is going to, so can we say something about if this one is working better or another one, or does it matter in terms of the users in different ISPs? So that led us to building the tool called Pytomo. And so the next few slides I'm going to talk about Pytomo in summary and provide it, summarize a few things about it. And then we'll talk about some of the measurements we did to show you what we found. So it's actually what we try to do is that after a lot of discussion and whatnot, it's a tool, we built it in Python. It actually emulates a video player for YouTube on a browser. So, and for that, we actually trying to do a bunch of different things there, because we just didn't want to collect just for one video. And when a user watches it, they're going to just watch one video and then maybe go get a cup of coffee or get another video. So if we just build the tool and said, okay, please run it, and if they run one video, that's not sufficient for us to collect the data. So we actually build a couple of more things, which I will talk about in a second. So we wanted to, Pytomo allows us to actually collect the data precisely. And so this second part goes to the actively crawling it. So what we can do is that we have a sort of a simple algorithm which basically starts with saying that go to the default page of YouTube and pick the 10 most popular videos, and then you crawl based on the related videos for each of them and some randomly select a few more videos, and you can go secondary and a tertiary level of related videos to see what sort of things you can actually find out. And you can actually then ask the users to say that collect this data for a certain number of videos. So you can say 50 videos or 60 videos or whatnot. To make this process a little bit simpler for us, for this particular collection I'm going to talk about, we actually limited the first 30 seconds of video collection for any videos we hit. But that's not a limitation of the tool, which is just a configuration for being able to collect more data, and with the understanding that how does users actually notice differences in the first 30 seconds. And secondly, many people sometimes when they watch the video, they may not watch the entire video, they watch it and they leave it after 20, 30 seconds. So it gives us a pretty good sense about what it is we can actually do with that. And then we also added a couple of additional things. Obviously, one of the things we did was latency metrics. That means it's a ping test. So once we found the specific server ID, we actually ping it 10 times and then collect that information and along with the other things. This tool runs on Windows, Mac, and the Linux, obviously, and then the code is available from Google Codes. And if you don't remember the link, just search Pytomo, Pytomo. It will give you the link and you can download it. Running the tool up, sorry for this crowd to show it on a Windows example here, but most of the residential users who run it for us were for Windows, so we had to do it. The couple of basic pieces of information, it's a very simple tool. Couple of them are not relevant, but we still ask them for permission to run it, and then say how many videos you want to do it. We also make it very clear to the users that we're not collecting any personal information about you, what you like to watch as a YouTube video. The tool is randomly picking, first starts with the 10 most popular video and then goes to, related videos and pick those. So it is not your personal choice. So, and no personal information about the computer or anything else. We are actually about what you have watched it prior to we have collected. So that made it feel them comfortable in terms of this particular thing. So I kind of hit the first part already, which is that initial list. at any time, we found out that YouTube have a default set of 10 most popular videos. So if we focus on a particular time window, we can actually guarantee that these are the same videos. It may change in the next day or next few hours or whatnot, or next week, but at least it is consistent, so we can see how this is affecting that. So what the tool does that, it basically gets the first HTML page out of YouTube, and then we parse it. And by parsing that information, we actually get a bunch of very, very important information. And among that information is the specific domain name of the server that YouTube allocated to that particular user. So, and obviously information about the video. So FLV tags and stuff like that. And I talked about the latency thing. We can actually, so before we start doing the progressive download of the video, what we do is that we actually first do a ping test. We set it to default to 10 pings for each one, so that we have some sense of the robustness of the value that we receive. So, and then let's see what else. Okay, so we also get the metadata information. For example, the duration of the video that comes at the very beginning, the video length, what is the encoding rate, all that, those information we can get. And then to be able to do the playback, it's, as you know, YouTube does what is called a progressive download. And so we have two time trackers in our tool. One is called the download time tracker, and the second one is the playback time tracker. So we keep those trackers to play it out so that we can actually then find out if there's a stall, then we actually collect that information about where the stall was and how long the duration of that stall was. And if it again stalls again, we can actually collect that information again and whatnot. So a little bit about the FLV. It is what actually helps us a lot in terms of what we try to do it. The flash video encoding format has a bunch of different tags. I won't go into all the details there. It is listed there, and the presentation is obviously available from NANOG side. So when we parse it, basically because of the timestamp information, we know precisely when a video particular chunk is actually supposed to play. So if it doesn't get it or whatnot, that's exactly allows us to use those two trackers to find out if we got any problems and whatnot. So, so we already talked about a couple of things. There's another thing we needed to do is that we first needed to find out that actually how long before YouTube starts playing, you start being able to see the video being played. So usually there's an amount of a download time. We did a very controlled lab environment to run a bunch of different videos with the regular YouTube player. And we found out that basically it tries to do about 2 seconds of video before it starts playing it, so that it can kick that in, then progressively downloads the next chunk and go on, so that hopefully there is no interruption, but there might be different. Because it is the 2 second that we found out to be the precise time, we actually can find out a couple of interesting things about the initial data that is needed and the rate, and from that we can actually find out the exact start time for that particular video. So in the playback stage of this, then the buffering and any interruption, I already talked about that. I want to go into all the detail of this busy slide here. And basically what it is that what I talked about is that because we have built a simple algorithm so that we can collect multiple, when a user runs the tool, it can collect for multiple videos at a single run. So what it does, goes to the default page, finds out this, parses the page, then goes to the server, gets the information, does the ping thing, and then obviously goes downloads the video, and I progressively downloads. And as I said, for this particular set of runs, we set the default value to 30 seconds of the video so that we can get a better sense of what we got there. So that's about summarizes about the Python tool. And so now I'm going to talk about what we have actually done in terms of being able to collect data. We found that the collecting data turned out to be much bigger challenge than we wanted, we actually anticipated at first. In fact, we had a couple of false starts because we wanted to have at least sort of some control study that instead of people just randomly running at any time and collecting the data and just saying, no, I only collected 5 because I got busy, you know. So we actually ended up having to do a little bit of a work on that, and we actually found it that actually something actually worked very well, which is called students. So my colleague Yong Zhang, he teaches the introductory statistics course at my university. So Young is a good friend of mine. We have done other research collaborations. So he said that, well, I will ask my students to run it and we'll give them 10 points. And student said, okay, we'll do exactly when you want us to run it. And so, and then, they are happy to get 10 points, although they don't think that the 10 point is only probably 1/10 of a percentage of the entire grade. But they look at the absolute value of that number and they were very sincere to run it. So, that worked actually reasonably well for us. So why Kansas City? That was the thing. But I thought for fun, I'm going to list a couple of songs about Kansas City. Obviously, I'm not going to play it right now. One is called "Everything Is Up to Date in Kansas City," so that's why you got to run it. And second thing is that there's a very famous song from it's. I think it was a #1 hit from early '50s. I'm going to Kansas City. Kansas City, here I come. And believe it or not, you guys all know about it, that Google Fiber picked Kansas City for the first site. And in fact, their commercial they were running in Kansas City actually had the second song. They're playing it out to do that. So anyway, but to really sum it up, it was the convenience for us. And I bet you guys know where Kansas City is. I put that map in there because I gave this talk recently in Japan, so just wanted to make sure they knew where it is located. But the other obvious advantage of being Kansas City is sort of, quite central to the country. So if the YouTube servers are located in different places, we get a sense of how it is actually. And second important thing is that as you guys know, most of the fibers actually goes to Kansas City because of the railroad history. So, so we talked about the challenge part. I'm going to skip a couple of the things already, but we wanted to do a control study. We got the students to be able to do it. So we have, I'm going to talk mostly from 2 runs we did. One was a little over a year ago in December 2011, and we asked the students to run between 8 p.m. and 10 p.m. on Wednesday and Thursday nights, when we found that from our very preliminary assessment that found out to be the residential users use internet the most. So this way, users are obviously using, watching YouTube, but they're doing other stuff as well. So the background noise is also, without collecting the data, is impacting the service observed there. So the December call, we have that we collected the data for about 1,300 videos. We actually found that there are over 400 distinct video servers from which actually this was served for this number of users there. For the March collection, we have about, we actually had a longer this thing. We have about 2,400 videos that we collected the data, and it was from about 1,000 different video servers. So by video servers here, I mean the unique domain name ID of the video servers. Obviously, some of them are located in a particular physical location. That's, I'm going to talk about that in a second. We also did a more recent study in October 2012. I'm going to have one slide on that, but we found some interesting differences. I'll point out what exactly those things are in a few minutes. So we have 3 different ISPs actually we focused on, and I'll call them ISP1, ISP2, and ISP3. 2 of them are cable providers, residential cable provider, and third one is a DSL provider. unless you twist my arm, I'm not going to tell which one is what. But it's probably very easy to twist my arm to tell you what they are. The study can be sort of divided into two parts. One is about the video server selection dynamics, and second is about the quality of experience associated with the metric that we wanted to collect and how that is done there. So what we find out is that, let's see, that let me go to this red line is the one you want to pay attention to. So when we started collecting the data, what we found out is that once we parse the page, the domain name of the where the actual video for a particular user is served from has this particular form. The couple of things about the machine numbers or cache numbers and stuff like that. And then, but the most important thing is what is in the uppercase there, server underscore code. And what we found very interesting when we actually did the study, that all the server underscore code is actually based on having the airline code, so city codes. So I'll say DFW, which is obviously Dallas-Fort Worth, IAD for Washington, D.C. It doesn't mean that it is at the airport, obviously. It just tells us that those servers are located probably in that geographic vicinity right there. Orlando or SJC for San Jose, like that. So that basically tells us where it is coming from. And then when you have a number V1 to 24 or these are multiple different servers from that particular location. So we can then cluster them based on the location by looking at it that way. So this picture, so remember I said about the top 10 most popular videos, and we know that it's the same videos that all the users who ran for us actually accessed it. So let me explain this figure quickly. So what it says on the left, where I have ISP 1, 2, and 3, that means those are the users located in ISP 1, 2, and 3 they're accessing. On the right-hand side, without going into the V1, V2, all those details, what we did is the high-level server code ID there so that we can kind of group them together. So you'll see the first ISP1 at top, IAD, which is Washington, D.C. area. So it is serving a bunch of things, the videos from Washington, D.C. Then you see the second one is DFW, which is Dallas-Fort Worth. Then you see San Jose, Miami, LaGuardia, LJ is New York City. And last one is Dallas-Fort Worth again. But that one is different server code than the one I mentioned above there with 6G01. First interesting thing is that for ISP3, we found that it exclusively served from dedicated server sets. Okay, there is no overlap at all. For ISP1 and 2, we saw for some videos, remember it is still the top 10 videos I'm talking about, served from the Dallas-Fort Worth location, but a significant number are served from different locations. So this sort of tells us that probably for ISP3, has an agreement with YouTube to have dedicated servers providing service to their customers. ISP in 1 and 2, they may have some, but they might also have some spill or overflow policy based on that going to other servers there. So this is for the, when you look at it, so this is sort of, I captured it already. I'm going to skip that slide. So when we went to March 2012, we saw the same behavior in general. For ISP3, it was dedicated servers. But what is we found interesting, it's hard to read it at the bottom of that the ISP3, when in the December crawl, we had serving from Dallas-Fort Worth, we found that it was actually served from San Jose and Miami for that. So within a matter of 3-4 months, we saw that what they're using it the default for the users is actually changed there. So that means the architecture or the evolution is very important, how it changes with time. And then we do see some overlap between ISP1 and ISP2. That's why those crossover of those lines, you can see it there. So this is again the top 10 video, so we know this is the same thing and whatnot. We then look at, remember we said that we ask users to run about for 50 to 60 videos. So going beyond the top 10, including all the videos, then you can ask the question, does it mean that only the top 10 most popular videos, because of popularity, they are trying to service from dedicated server to get the customers see the better service, or do they do differently? So in terms of the general pattern, we found that even for all the other videos for ISP3, it is actually served from dedicated servers. And for ISP1 and 2, there is obviously some overlap there. So, so this is, I think it is better if I go to a table, and then you'll see what is going on there. And I'm going to talk about this along with my table in a little bit following that, because we collected the QA experience. So let's go to the table here. I don't know how it is easy it is going to be able to see whether you can, for you to read it. So I'll start with the thing at the bottom of the table, which is the ISP3. So the ISP3, we had about 240 videos in the December crawl. And then, as I said, it was in Dallas-Fort Worth. That's why in the March is on the right side of the column. There's no overlap there at all. But that's where the San Jose and Miami showed up there. And you will find out that they have the number of interruptions very little, were less than 1% in both cases. The download rates were close to 2 megabit per second. And average start times were all less than 1 second. That's what you can see there. So for ISP1 and ISP1, there is also one overlapping server that we see from December to March. And so you got that information. For ISP2, which is, then you see 2 of them overlapping. But if you look at more interestingly, that information that you want to see is that there is actually, we can get for a particular server location, how it is actually behaving or impacting the observation there. So you can see that there's a place there. We got, it's even from this angle for me my eyes are not good anymore, hard to read it. That you can see that one place there's 54% interruption we saw there. And I'm looking at the March column towards the bottom of the ISP2. And it was about 44 videos. That one and the next one, I believe, are from the same sort of the location, but the other one actually had lot less interruption. So that tells us this particular server cluster is actually probably experiencing some problem. The other interesting thing you'll expect and correlate being able to see it, so is that when you have more interruption, that your download rate is less, and also as well as your start time is up. So you can see those information there. So I kind of captured that. We have the content distribution, cumulative distribution functions that we have plotted. So I'm going to skip a couple of those things. It's on the slide, you can ask me. And then we see differences from going from December to March in terms of how users. So you can, if you're interested, looking at what happens to 95% of your users in terms of performance they get, we can actually calculate those informations from what it is. And so similarly for initial rate, we have that information. We did some statistical tests to be able to also say what is the significance in terms of difference between the December data set and the March data set. And interruption part of it, we got information about that in a 30-second clip. One thing good about having all videos being 37, we can actually, it's a normalized value for the number of interruptions that you can look at it. So we plotted out the distribution information for how long was the interruptions. So you can see that one ISP, for example, ISP2, the service got, in a sense, worse in March 2012 compared to December when we look at that particular measurement. Obviously, these things can go up and down. You know that, but I'm just saying that if you do a spot test in terms of a control environment, what sort of things you actually see it. We also, this plot is kind of telling you about the ping test that we did, the latency test. It tells you about, by the green circle means it is less than 50 milliseconds from Kansas City. The blue is the 50 to 200 milliseconds. The red is more than 200. So you can see that the Miami, which is actually closer than San Jose, has more latency that we observed than San Jose, for example. So this is one advantage of looking from a geographic context point of view, how that. So though what happened to the new data set? We found a very interesting thing. The folks at YouTube decided to do something different. They changed the server code naming. They don't have the airport city code anymore listed there. That really threw it off the track. But because we have been collecting data, not necessarily the two data sets, some other stuff, we could actually go back, look at the IP address, and correlate it, being able to kind of say that, okay, these do belong to San Jose from what we have. The ones we are not sure, we put it as an others. But you can see the similar pattern in terms of how actually being served from by different ISPs in that. So to summarize, basically, the Python we found it to be a very useful tool, and I thought one of the reasons I came to give this talk here, I thought many of the residential ISPs might be interested in seeing how their customers are actually facing in terms of quality of experience. But second important thing with it is because we get a little bit more information about that content distribution. So then if you can actually go complain to YouTube and saying that, well, this server thing, which is serving my customers, it was not doing well at 10 o'clock in the morning on a Saturday morning and whatnot and things like that. So with that, I will stop here and I'm open for questions.
Brian Hitz from Cable Labs. So the tool that you've developed is meant to be run at the client side, right? All the statistics are collected at the client side?
Absolutely, yep, right. Mm-hmm.
So I guess the dilemma there is if I'm a service provider and I'm deploying an all IP video solution, that doesn't give me much leverage to collect statistics as an operator.
Yeah.
We need to build applications that can collect performance metrics and feed those into an operator, right. NOC.
So there are a couple of ways that can be weak, actually. First thing I want to point out is that my partner, friend Louis, who did it part of the project, French Telecom is actually in their DSL network, is actually deploying it. And they are doing it a little bit differently. So let me quickly comment. So they have quote unquote homes located in different parts of the country from where they are actually deploying the tool. The second thing is that if you can have some customers with some some incentive, and not like my students, obviously, they say that, okay, if you download and run this, we'll give you a 2% right. discount or whatever on your service. They can actually run the tool for you and then collect the data. Sure. And as I said, we don't collect any privacy information about it, and whatnot. So there are a couple of ways. Also, I'm also looking into that, and that's the other reason for coming here. What are the ways to be able to partner it to collect data from different sites?
Right, and we need to move to some standards where perhaps in the gateways we have more execution environments that are standardized where operators can push down applications.
I thought that as a part of a software client or something, if we can push it, that'll be great, and I can talk to you offline right after the talk. But
I think some users are definitely against letting operators push applications down into their environment and running them.
I mean, and it has to be an opt-in.
Yes, and collecting metrics.
No question about it. So
right,
you have to figure out. Thank you. Very good.
Sorry, guys. Unfortunately, we're running a little short on time here, so we'll have to cut this short. If you could take your questions with Deep outside, that would be great. Thank you very much.
Thank you. Okay.